Welcome. Today we will be discussing basic electronic devices, the basic ones. Okay. By the end of this lesson, you should be able to sketch the structure of an atom, state the processes of electron emission, identify basic electronic devices and their symbols, list the uses of the devices, and explain the operation of the devices. Now, we know that electronic devices exist, and we have electronic appliances in our homes, ranging from your laptops or your computers, ranging from your television sets, the remote control you have in your hand, the GSM you have in your hand. They are all electronic devices, right? Now, these electronic devices, like we do know them, right? The major operation in them is that they emit electrons and redirect these electrons to move in a certain way in the circuit they have. Now, these appliances we'll see in our homes, there's where they started from. Everything around us has a foundation. So we want to start from the foundation of all these macromolecules we'll see, all this equipment we'll see in our homes today. We want to talk about the genesis of it. You already know that every element has an atom. Every element has an atom. That smallest part of that element is called an atom. We are discussing this because of electronics. We cannot talk about electronics without talking about electrons. The word electronics came from electrons. So let's talk about electrons. What are electrons? The basic atomic structure. Let's understand it. You already know from your basic school that an atom is that smallest part of an element, all right, which has the same properties as the element. Now, in the structure of an atom is said to have a massive nucleus. In this nucleus, we have the proton, we have the neutron. The protons are positively charged, like you know, while neutrons they have no charge. Both of them make up the nucleus that we have. Now, we also have another subatomic particles we call the electrons. These electrons, they actually exist in orbitals in different positions, right? In the shells or levels, energy levels in the atom. I don't want to delve major into that. We are just in basic school. Now, these electrons, we are made to understand that they spin, they move round, and they are held by an attractive force that exists between the proton and the electron. This one is negatively charged. Electrons are negatively charged. They have negligible mass. They have mass, but it's negligible, right? Yes. So the negative charge in the electrons and the positive charge in the proton, they make this atom to be neutral. That is why, you know, the mouse I'm using for this video is not shaking, it's stable, because the atom is made up of is stable. We can have everything around us and tell you that this atom here is neutral. So it's stable. Every neutral atom is a stable atom. That is the import of what I'm trying to let you understand. And everything we see around us is made up of an atom. So electrons revolve around the nucleus like we see here in its orbitals, right? Now their movement, the way these electrons move, if they move, they can move in a solid, they can move in a liquid, they can move in gases. If electrons move in a solid or move in anything, of course, electrons cannot just move in a solid that is not a conductor. I'm trying to code the word so that you understand. Now, when electrons move in a solid, we call conductors like wires. They constitute what we call electric current. current is produced in the process. Same thing happens also. Electrons can also move in liquid, like we have in electrolysis, for example. All right, we have the electrons there produced, the charges produced there, right? Now, well, in gases too, when you subject gases to a high voltage and a low pressure, you will have them disintegrate, and electrons are produced in that process. They conduct, electricity. They produce electrons. Now, in electronics, the movement of these electrons is what we want to actually talk about. How do they move within different components or devices that make up the appliance that we have? Let's progress. All right, now, electrons on their own, when they exist in an atom on their own, these electrons can be knocked off from an atom. And when electrons are knocked off, or when electrons are released from the surfaces of their conductors or surfaces of metals that have them, right, we'll say emission has taken place. So we will talk about electron emission, because this is exactly what electronics, what they do. They emit electrons, and now the electrons emitted follow a certain path, and that's how the gadgets we see around us today, that's how they operate. So electron can be emitted in different ways. Electrons can be emitted, by passing electricity. Electrons can be emitted when sunlight or when photon from the sun strikes a metal surface. We're going to talk about it. Let me just carry on a little bit here. Electron emission simply means the release of electron from the surface of a conductor into a space immediately surrounding it. When this happens, we say electron emission has taken place. This emission can take place in 4 ways. Electrons can be emitted in the surface of a conductor in 4 ways. Number 1, it can happen through a method we call thermionic emission. We're going to talk about it. It can also happen through photoelectric emission. It can also happen through field or cold emission, and it can also happen through secondary emission. Now, when we say electrons can leave the surface of the conductor through a process called thermionic emission, will simply mean that when you heat metal, for example, when you heat a metal surface to a sufficient temperature, that, of course, you already know that when you increase the temperature of any material, right, that the kinetic energy increases. I want to limit myself to this topic. You already know. So the electrons acquire energy, When they acquire energy, the energy, as you keep heating it, they keep acquiring energy to the extent that this energy acquired is enough to break off the attractive force that exists between the protons and the electron, right? So at that point, the electron is emitted. Now this emission can be directed. We'll talk about it. It can be directed through the circuit or through these gadgets, and we are having what we're having today as monitors of computers. We're having what we're having today as our home theaters. We're going to talk about how these things work. Now, when this electron emission is caused by heat, we call it thermionic. Thermal means heat. So thermionic emission simply is the release of electrons from the surface of a metal when heated to a sufficient temperature. Now, in practice, this heat is actually obtained from filaments. Previously, I've told you about conversion from electric energy to heat energy. This filament is just a coil of wire, right? Of course, you know about nichrome and all of that. When electricity is passed through this filament, what happens? This filament converts the electric energy that is passed, to heat energy that way too. So we see streams of electrons being emitted when the filament heats to a certain temperature, such emission is called thermionic emission, like you can see from what I'm showing you here on the screen. This is a hot filament here, heated. Now when heated to a sufficient temperature to liberate the electron, we see the electrons here, you know, being emitted. They are in motion. They've started moving around the space here. Okay, when they are controlled, we can have them using different things, but we'll get there. Just follow me gradually until we get there. Okay. Now electrons can also leave the surface of a conductor through a process we call photoelectric emission. Photo here means sun or light. Photo here means light. Now, if UV light, for example, is meant to fall on, you are just in basic school. Let me use this words like that. It's meant to fall on a metal. Now, as it keeps falling on the metal, it will get to the point that the electrons in the metal, as they acquire these photons from from the sun, for example, they will be able to escape. They will be able to escape the binding force, or the energy that is binding, or the attractive force that's keeping the electrons in place. All right? Yes. So when that happens, when that emission of electron is caused by light, we'll say the emission is called photoelectric emission. We also have an emission we call field emission. This is a case where we have electrons emitted when we have conductors placed in a strong electric field. This one we call it cold emission. Thermionic emission can be called hot emission. You know, so we just want to use them to differentiate what is happening between the two processes. But the two processes, they all involve emission of electrons. So when we have these conductors placed, of course you know that we have the electrodes, all right? We have the cathode, we have the anode. The cathode is negatively charged, or the negative electrode, you know, while the anode is the positive electrode. So when you place them in an electric field, of course, you know, the electrons actually are moving. When we have electric field, it means that we have electrons in motion. Now this field can knock off electrons from the electrolyte, from the electrode, especially the cathode. Now when this happens, we'll say it's called cold emission of electrons, right? That way we'll call it field emission. We also have another method. Electrons can also be emitted from the surface of a conductor. We call it secondary emission, all right? This way, it's just when we have a stream of electrons produced, right? Knock off electron from a surface. In this case, it could be a phosphorus surface, all right? So this kind of emission is the kind of emission that is utilized in the monitor of your computers, even in the fluorescent tubes. That's exactly what plays out in the fluorescent tubes, right? Where we have fast-moving electrons, you know, cause electrons to be emitted from other surfaces. When that happens, these electrons glow. We'll say, oh, the tube, the fluorescent tube is glowing, and so on and so forth. So such emission is called secondary emission. All right. Now this is a case of photoelectric emission. You see here the light rays that fall on this metal, or you say that is incident on these metals, cause electrons to escape or to be released through the surface of this metal. We call it photoelectric emission, please. Take note of that. Now, it's important we discuss these basic electronic devices. Now, the basic electronic devices, when we have all of them put together, they make up what we call electronic appliances, right? Now, these devices we're going to mention to you now, right? I told you earlier that they operate on the principle of electron emission, electron movement. If electrons are not in motion, they will not operate. So they operate basically on electron emission and the movement of this electron that is emitted within a certain path in the circuit, or what we say in the board. Okay, now what are these electronic devices that we've been talking about? What are they made up of? They include resistors, they include capacitors, they include the vacuum tubes. Here we'll talk about diodes and triodes, right? We also have the transistors, the IC, what we call the integrated circuits, the inductors, and the circuit boards. All these are what we regard as electronic devices. When we have them connected in a circuit, right, we produce electrical appliances. If you open any electronic appliance, right, you will see them. You will see a resistor, you see a capacitor, you see an inductor, you see a transistor, depending on the electronic device, electronic appliance, and what the purpose is for. So we're going to talk about these electronic devices, their structures, and explain how they work. So I need you to sit back as we delve into their discourse. All right, here are different basic electronic devices. Their symbols. It's important you know how we can, see them. When you see their symbols in a circuit, you should be able to interpret that, hey, this is what this is talking about. Now we have a resistor here, a resistor. You can see in your electronic device appliances, this is how you're going to see most of them. This is a resistor here. The symbol is this, although this is for America. For Britain, we have a box, like a box here with a little line out. That's for Britain, but this is for America. This is its symbol. We have a capacitor. All right, we have the capacitor here. Of course, you can see that this is charged. So we have a capacitor. How do you differentiate a capacitor from a cell? Simple. In a cell, for example, here we have the positive terminal here is longer than the negative terminal. So with that, you can differentiate it. But for a capacitor, the two arms here are of equal length. So this is a capacitor. This is a diode. This is a Zener diode. We'll talk about Zener diode when we talk about diodes. This is a transistor. All right. We have a diac. We have a fuse here. We have a DC motor. And we also have light emitting diodes here. That's what you're seeing this. These are diodes too. All right. We call them light emitting diodes. This is a symbol of a fuse. This is a symbol of a battery. This is a variable resistor, so to say. We have this and an arrow here and all of that. So let's go to discussion of these devices. We have number one on our list here is a resistor. It's a resistor. Now a resistor basically is used to control the flow of current in an electric circuit. Or have you not asked yourself this question? Why do we need a resistor in our appliances? If you don't control the amount of current that enters the appliance, right, then it will flash other components that we have that may not be able to tolerate such current. So it has to, control the amount of current that enters. So we can also say, right, so these resistors that control the flow of electric current in the circuit, right, they offer what we call resistance to current flow in the circuit. So we can say that resistance simply means the opposition to the flow of electric current in the circuit. We have different types of resistors, like we've shown you on the screen here. We have resistors we call fixed resistors. This is an example of a fixed resistor. We also have another resistor here we call the LDR resistor. We have the thermistor, we have the varistor, the rheostat. Rheostat you see here is a typical example of a variable resistor. Those resistors that don't have fixed values. But for a fixed resistor here, it has a fixed value. You can have it as 10 ohms and all of that. Resistance of a resistor is measured with an instrument we call ohm meter, and the unit is called ohm. It's important you know all of this. We won't delve deeper. We'll just stop at this point so that we'll not go beyond the scope of this class about resistor. All right, I've told you the meaning of resistors, what they do, resistance, types of resistors, and all that. Okay, so here we have types of resistors. We have the fixed and variable. This is a rheostat here, a variable resistor, and all of that. Now, another component, important device that we have in electronics appliances is called a capacitor. A capacitor simply is a device that is used to store electric energy in a circuit. You can say it's used to store electric charges in a circuit. All right. Now, this is a typical capacitor. When you open your radio, transistor radio, you must see this. Obviously, you must see this. It's called a capacitor. It stores up electric charges. All right. What it does is that it has a way of delaying the voltage, has a way of reducing the voltage that flows through the circuit. All right. It does this storage in an electric field. So, a capacitor stores up electric energy in electric field. Okay. Now, the ability of a capacitor to store electric charges is what we call the capacitance of the capacitor. It's actually measured in farads. It's what we call the capacitance of a capacitor. We have different types of capacitors. We have the fixed capacitors. They have fixed values of fixed capacitance. We have the polarized capacitor. That I showed you previously is a typical example of a polarized capacitor. This here is a polarized capacitor, right? It's a capacitor that has polarity. That's where that name came. We also have variable capacitors that don't have a fixed capacitance. So they can vary depending on how you actually alter what is going on within the capacitor. Now, for a capacitor, we have the supercapacitors. This you see oftentimes. You can see this in your sumo pump, or in some generators have this. We have the ceramic capacitor. This you see basically in some devices. You open this. This is a capacitor. So when you open your appliances and you see this, please know that they are capacitors. Their major work is to store up electric charges or store up electric energy. When the light is off, some of these electronic appliances, they don't like that abrupt, power outage. So this helps to, put to use back the electric energy they have stored, so that the appliances can, on its own cool off or maybe die down. All right. Now, a capacitor, for example, a capacitor has this structure. A capacitor is actually made up of two terminals, all right? We call the electrodes of the capacitor. And in between the electrodes is a material we call the dielectric material. This dielectric in a capacitor is actually an insulator. The capacitor that has these dielectric materials can store up electric energies more than the ones that don't have dielectric materials. So it's important we know this about the capacitor and what it does. I said it is used for storing electric charges. That's what we use the capacitors for. Capacitors are specifically used for storing electric charges. When we have abrupt outage in power, some other appliances may not want such outage. So capacitors give out the energy they stored again so that the appliances can die down. Okay, this is the much we can talk about in this. We still have so many other appliances we have, and we're going to discuss them now. I need you to just watch my video on other appliances. Okay, but for now, we want to take some exercises. We want to take some exercises from our app, the ExamGuide app. I told you that this app is an app for every student, so long as you're in basic secondary. So long as you really want to do well in basic technology, I recommend it for you to please use this app to practice. Remember I said that practice improves you as a student, but when you don't practice, you'll just be at the mercy of your teacher alone. Okay, so let's look at this. The device in a circuit used for storing electric charge is, please answer this one. Okay, good. That device is called a capacitor, not an inductor, not a resistor, not a transistor, not a diode. We're going to discuss all of this in the next video. Please, I really want you to please watch the next video. Okay, let's also look at other questions. The electronic component that operates the flow of current in circuits, that opposes, you see that opposes the flow of current in the circuit is a capacitor, a diode, an inductor, a resistor, a transistor. The answer is a resistor. It opposes the flow of electric current in the circuit, and it controls the current that also enters the appliance. Thank you for your time. See you.